Hey guys, welcome back. This is going to be 5.4. We're still talking about graphs today, but we're going to talk about the other graphs. And we're not going to talk about transformations or anything. And right now, I'm not planning on having any homework for you guys for today. This might be a little longer video, so this will be your only homework. As long as you understand how we get these graphs, that's fine. Um, you probably won't have to graph these by hand ever. I know in calculus you'll have graphing calculators, so instead of spending a lot of time working with these, I think you'll just use that. But we're at least going to talk about how you find them because that's important. So first, let's talk about secant of x. Now this graph, if we look, is just cosine of x. This graph is cosine of x. And remember, cosine of x equals 1 over, oh, sorry, did that backwards. Secant of x equals 1 over cosine of x. Okay? And so we're first going to start by labeling a couple of points where our value is 0. So on cosine of x, it's 0 right there, right? Right there, right there, right there, and right there. So let's look. Secant of x is 1 over cosine of x. So at these points right here, secant of x would be 1 over 0. Well, you can't divide by 0. That's undefined, right? And so as you learn in Algebra 2, if that happens, you'll have something like a vertical asymptote because you can't have 0 in the denominator. So I'm going to draw these asymptotes. Now because cosine goes on and on and on, this would go on and on and on forever and ever and ever. So there would be infinite vertical asymptotes for these graphs. So these are going to look a little different. Well, now let's think about it, okay? Secant of x is just a reciprocal of cosine of x. So at 1, at this crest, the reciprocal of 1 over 1 is still 1. So secant of x would have a point right here. But then all these values right here, they're all less than 1 but positive, right? If we're looking right here, all less than 1 but positive. So let's just say, I don't know, let's just say this point right here is 0.5, right? So cosine at that point is 0.5, and we can always put it as a fraction over 1. 0.5 divided by 1 is 0.5. Well, in secant, it's 1 over cosine, so it's reciprocal. So it'd be 1 over 0.5. Well, 1 divided by 0.5 is 2. So all these values that are positive but less than 1 become greater than 1 then. Okay? And so what our graph is actually going to look like, this, I know it's sloppy, it's kind of like a U, looks kind of like a parabola, and it'll keep going and going and going because the closer and closer you get to 0, that smaller that decimal is. So you'll be dividing 1 by a really small decimal. So you'll keep going up and up and up, but you'll never cross these axes. Now let's look at this negative one. Okay? If you look right here, this point is at negative 1. Well, you can write that as a fraction, negative 1 over 1. The reciprocal of that would still be negative 1. So we still have this value here. Now, same thing. Let's say this is negative 0.5. Okay? So all these values are negative and less than negative 1 right here. If I picked negative 0.5, well, that would be 1 divided by negative 0.5, which would be negative 2. Okay? And so all these values, all these decimals that are smaller than 0 but not past negative 1, the reciprocal of that will be negative numbers less than negative 1. So on the negative end of things, it's actually going to be downwards U. And then it hits that crest there. And so these are actually pretty easy to graph without transformations. The positive ones will just be U's going up, and on the negative side of things, U's going down. That was a terrible one, sorry. And so that's what secant of x looks like. And so as you can imagine, that's pretty weird looking graph. Remember, the red isn't even technically part of the graph, it'd just be these blue U's here. So that'd be pretty interesting to graph by hand a bunch, right? And so as long as you know how we got that, you're sitting in good shape. Well, almost the same idea. Cosecant. Now we're looking at sine. Now keep a note that the asymptotes are at when the equation equals 0. So the asymptotes aren't the same for cosecant and secant, right? It's for sine, it's 0 at 0. For cosine, it's first 0 at pi over 2 or 90 degrees. So they're different asymptotes, okay? It just depends on where the sine or cosine function is 0. So we look at where there's 0, and that's going to be our vertical asymptotes. So I'm going to draw that. And you could verify all this on Desmos. You could easily graph a sine and cosecant function at the same time, and you would see that it looks like mine, hopefully a little neater. But we're drawing our vertical asymptotes. And then it's basically the same thing. Cosecant equals 1 over sine of x. So again, when sine of x is 0, well, we can't have a value for cosecant. It's undefined, so we have our vertical asymptotes. Then here, we use the idea of reciprocals. It's just going to be more u's going up, and when it's negative, going down and up. Okay? And so very similar, they look the same, they're just in different spots. Because sine is 0 at intervals of pi, so 0, pi, 2 pi, 3 pi, okay, which is different than cosine. So now we're going to look at tangent of x. Now that's what the graph of tangent of x looks like. Let's go to a website and talk about this. Let's see. So remember, tangent is y over x. So we have to keep that in mind. So y over x, well, we need to think, when will x be 0? And remember, on a unit circle, I'm not sure why I said that weird, x is basically our cosine, right? So when is cosine 0? Well, cosine 0 at 90 and 270. So 90 and 270. And so, well, where's my PowerPoint? That would be where our asymptotes would be. So we have our asymptotes when our x, let's see, sine of x over cosine of x. When cosine of x is 0, then we have a horizontal asymptote. It would be pi over 2, which is 90 degrees. And then again at 270, which would be, what, 3 pi over 2. So they're not, I don't have them labeled on here, unfortunately. And so on and so forth. And so that's how you get your asymptotes. Again, you'll have infinite asymptotes. Let's go back to the website. And so it's a ratio of y over x. So when you start off at 0, well, your y should be 0. I'm just a little bit off. And your x should be 1. So it would be 0 over 1, which is 0. So you start at 0. And then if you think about it, it's y over x. So if as you're starting off, your y is smaller than your x. So you should get a value smaller than 1. And then, eventually, you'll get a y and an x to be the same, which would be at a 45-degree angle, right? Your y and x would be the same, and so tangent would be at 0. Or tangent would be 1, sorry. But then here, your y starts to get bigger and bigger and bigger, and your x gets smaller and smaller and smaller. And since x is on bottom, the closer you get to this 90, the larger the value, and it's going to get very, very, very large. Technically, it could get infinitely large, okay? And then you get that asymptote, because we have x is 0 and that divides, so we have an asymptote right here on the graph at 90 degrees, kind of like what I drew on the PowerPoint. And then we keep going. Again, our x is really small, but it's negative now. So all these values are very large negative, so it's off the graph down here. So it's past this asymptote, down here negative, and that x value is still going to stay negative, except now it's getting closer and closer to 0 because the x's and y's are getting closer. And then the y's start getting smaller than the x's, so they're really small decimals, but still negative. And then you hit this point here, -1, 0, which wouldn't be undefined because the x isn't 0. Well, now both the x and the y are negative, so negative divided by negative is a positive, so it'll keep going up and up and up. And then you hit that asymptote again. Come on. Asymptote where x is 0, so we had an asymptote right here, and now again right here. And then finally, you have your x's are positive, and your y's are negative. So these are all going to be negative. Similarly, they're still going to be very, very small, large negative numbers. But as y gets smaller, we're getting closer and closer to 0. So we just made one cycle from here to here. And then similarly, you can see if you keep going, it just repeats over and over again. So that's how you get tangent. Again, probably won't have to do much. It is important to know in trig when it's undefined, and that's just when cosine is 0. So you just got to think, when is cosine 0? Okay. Let's go back to the PowerPoint. And then reciprocals. Well, the last one we got to do is cotangent. So the reciprocal of tangent equals, away from current slide, equals 1 over tangent of x. So we need to know when tangent is 0. Okay? And that was, tangent was 0 equals sine over cosine. So when sine was 0. Okay? And so tangent was 0 when sine was 0. And that would be, well, it starts at 0. So there, we have an asymptote there. Okay, and then at pi again, 2 pi, 3 pi, so increments of pi was when tangent was 0. And that's not the asymptotes on tangent, it's just when tangent hit the x-axis. But cotangent is the reciprocal, so when tangent was 0, cotangent will have these vertical asymptotes. So again, infinite amount of vertical asymptotes. But then it's the reciprocals. So if you think, well, let's see, when tangent kind of looks like this, right? If you have values down here, they're very negative, right? But if you take the reciprocal, sorry, you get a value closer to 0 then, but still negative. And so it's the same kind of process. You could think of it as cosine over sine. So back on the graph, it'd be the comparison, the ratio between cosine and sine. So I'm not going to do the same thing, just because you can imagine on that circle that I used for the demonstration, instead of sine over cosine, it'd be cosine over sine. The asymptotes are basically, the asymptotes are different. And then the graph in between these asymptotes are basically flipped, because last time it started in the bottom left very negative and then it got positive. Terrible drawing. Now it's almost reversed. So if I were to graph this by hand, I would just draw my asymptotes, and then if it's, it meets in the middle at 0, that's what all these have done without transformations. Then if it's tangent, I would draw my little things in the middle like this. If it's cotangent, it's the reverse, so it starts at pi and goes lower and lower and lower. Okay, but again, you're probably not going to spend a whole lot of time graphing these by hand. I don't recall doing that, although I don't have the best memory. Okay, so that should be it. There is not going to be any homework. Just understand how we got those. These are vastly different than our sine and cosine, which is what we spend the majority of our time on in terms of graphs. Okay, so if you have any questions, feel free to ask. There are tons of resources out there. Tomorrow, we're going to talk about graphing inverse functions. Remember, these aren't the inverse functions. The inverse is like sine inverse, cosine inverse, tangent inverse. Okay, so with that, I will see you guys tomorrow.